We're back here at the lab, and this is a continuation of what we've done the past couple of days with high lines. In quick review, we built the track line and we had the control line for our basic high line system. Now what we've added to it is a third component, which is a Reeve line. This is going to allow us to go down from the carriage system that we'll go look at here in a minute. Allow us to go down, do our rescue, bring that rescue package back up to the carriage, and then back to the side again. This would be something that might be used in much deeper scenarios, like in canyons or deep cracks, slot canyons, that sort of thing. What do we have here? Well, it's a 3-to-1. So you can see the Z-rig. We're going through a pulley, just a standard progress capture, pressing winding pulley. The 3-to-1 is now pulling on a 2-to-1. So let's go over here and focus on the carriage. What we're looking at here is another modification from the previous element that we just talked about. You know, recapping the other one, we had a single Kootenai carriage, and it was a Norwegian Reeve. Basically the same mechanical advantage. We still have a 6-to-1. There's a 2-to-1 here, and over on this side there's a 3-to-1 pulling on this leg. So that's not really changing too much. The big difference, if you remember, on the Norwegian Reeve, this leg right here terminated at the pulley. Now we've added 2 pulleys, and that's what we're going to talk about. And this leg is no longer terminated here. Instead, this leg is going all the way to this side over here, and it's connected to that anchor over there. What that does, a couple of things. The Norwegian Reeve, you're continually playing out this rope, or you're going to have up and down movement of this load as you're hauling that direction. The English Reeve, on the other hand, because it's continuous all the way, either direction, as this carriage moves one way or the other, our load will maintain the same height. This rope simply travels through the system as we're moving right or left. Now the attendant still has to tend the opposing pressix, okay? So if he's going to the left of me, this pressix would want to lock up, and he'd have to tend that during travel. If we're going to the right of me, this pressix would lock up and he would have to tend that. Conversely, if it were reeving down, we're letting rope in this direction, this pressix would be tended by itself. This one would lock up if he did nothing, and then we'd have this dead leg and we'd have to correct that. So when we're going down, the attendant would tend this pressix. This one would take care of itself. When we lift them back up, we're going from the canyon back up to the carriage system, this pressix is the opposite. He'll start tending here, and this one would want to lock up, so we would have to tend this one. And you can quickly see the movement of these things. They're very dynamic and almost like they're alive, and they'll tell you which way you need to tend these. And this is kind of like the Cadillac of reeving systems. You know, you've seen 3 different types of reeves within these series. You saw a reeving system with an Aztec that allows for a limited amount of up and down. You saw the Norwegian Reeve that terminated on a single carriage. And now we got this Cadillac system, the double carriage system with the English Reeve. The double carriage system, this has an advantage to it, and there's a disadvantage too. The advantage is we have separation here. If you remember with the Norwegian Reeve, we went down and straight up. So these legs were much closer. When you're reeving down into the canyon, you're going to get a couple of twists in this thing. This package will twist around, and so these legs will intertwine around themselves. Not a big deal usually, because it tends to correct itself as you bring them back up. It's still something worth managing. With the separation here, it looks kind of wide right now, but as we lower this several feet, sometimes hundreds of feet down into a canyon or a gap or some kind of slot canyon, you'll see this beautiful looking pennant of this rope system going down, and there's very little, if no, twisting of the load. Just because this space here, this thing is very nice. It's like an elevator. This is literally our elevator system of our high line. We have a high line that's going left to right, And we have an elevator system. When we rig a reeving system, we have this elevator that allows us to go up and down. We have the 8 shock absorbers once again. This is kind of new concept in the way a lot of people have traditionally reeved or built and rigged high lines, Kootenai high lines. We'll also do some demonstrations on the more traditional pressic bypasses. I'm really liking these shock absorbers though. We still have the knots that are going to grab this load, but we're taking the hit off these knots by interfacing the shock absorbers. I really like this, this larger one right here. It kind of gives a little stability between these two carriages and the way they move back and forth. A lot of times you would just have a pressic right here, and it tends to be a little floppier. So I like the rigidity of this particular shock absorber right here. It's a continuous loop, so it never really separates. Matter of fact, before this completely deployed, we would have loaded the knots. But the knots would have not have had a shock load to them, so that's the beauty part about this. These start deploying at 2 kilonewtons. If we had a larger load, we always have the option of doubling up on the shock absorbers to where we could have a 4 kilonewton deployment. And typically I would do that at the anchors on either side. This right here, I'm satisfied with the testing that we've done, that when these deploy, they deploy at such a rate that these knots do not receive a shock load, and that meets our traditional criteria of using this as a shock absorber for this overall system if it were to fail. Once again, it's very clean. The guys that rigged it up did a marvelous job. You know, they're still putting their knots, for instance, on the spine of the carabiner. We don't see this stuff moving on the gate. Same thing right here with these pressics. We're using the bound loop pressics. The Sterling bound loop pressics are marvelous for this kind of application. It holds really nice and tight. Extremely clean. This is kind of a grandiose looking thing, and it is, but yet being able to rig this, being able to have the skill set to put this together raises your overall rigging aptitude. So on any given day, you could use some of these concepts on the simplest of rescues. It's not just the type of thing that you would use just on an English reeving high line. Arguably, you could go your whole career as a rescuer and never have to do this. But from a practice standpoint, hey, it's hard to beat. You know, and when we go out and do this out in the field, it's great fun, first of all, and many times that's the driving force for me personally. And yet there's an awesome education in looking at some of the physics behind this stuff. And we're really almost just scratching the surface on this when you start studying the physics behind the deployment of shock absorbers, or what are the actions and reactions of pressics and how do they interact with rope, whether they be opposing pressics, whether they be bypass pressics if they were in this position, what kind of high line, track line are we rigging? Is it the single? Is it a twin? Is it a quad bundle? And then the associated tensioning systems. There's a lot of theory and a lot of understanding and years of training that a person can spend in rigging. And a lot of this is kind of culminated in some of these big things like this. It's good stuff.